Section 6.3 is all about vectors. We're just going to touch the base level of vectors, not going to dive deep. Excuse me. If you take physics at any time, you'll talk about vectors. Vectors is basically what they do is they represent quantity that has some kind of magnitude, which means it has a length that it is and it goes in a direction. So what we're going to talk about with vectors, we're going to be real basic. How to find the component form if you're given 2 points. How to find the magnitude. How to find the unit vector. What do you do if you want to find a vector in this direction that has a different magnitude. How you find vectors that way. We're not going to go in real big detail, just the basics. So these are basically your formulas that you need to know. What is a vector? Well, it has an initial point and a terminal point. It goes in a direction. This is the symbol for what a vector is. Okay, so to find your component form, number one, if you'll notice, these are not parentheses. It's like your open arrows, kind of like brackets, that represent vector. The biggest thing to remember on this, when you're finding the component form, it is terminal minus initial. So if you're not given, like we did this first one, I'm only given P and Q. Initial would be first thing in the alphabet, terminal will be the second thing in the alphabet. Okay? That's how you find the component form. That's the biggest thing to remember, because if you go backwards, you're going to have your signs all messed up. Okay, the magnitude is the length of that vector, however long it is. It's essentially the distance formula between the 2 points. If you already have it as a vector, you've already done your component form, you could just square each part individually, add them together, and then do the square root. If your magnitude is 1, then we know that's a unit vector. And if the magnitude is 0, we know it's a 0 vector. And then to find the unit vector, after you find your magnitude, you would take your vector divided by whatever that magnitude is. Okay? So if I'm going too fast, you can always stop the video before going to do the example problems. So the first thing we're going to do is we're going to talk about how do you put in component form and find the magnitude. Well, this is written as 2 points. It doesn't tell me which one's which, so I know the first one in the alphabet is going to be my initial, second one's going to be my terminal. So it says you're going to find your vector, you do terminal minus initial. So I would do -1 minus 4, and then 5 minus -7. So minus and negative turns into a plus. And then I would just simplify. So my vector would be -5, 12. Okay. Then to find the magnitude, since I already have it in vector form, it's the square root of each part squared. So -5 squared is 25. 12 squared is 144. So this would be the square root of 169, which is 13. If it's not perfect, then you do your factor tree and you break it down as much as you can. So that's component form and magnitude. Okay, so if I do the same thing on number 2, if I want to find my vector, now this one tells me initial and terminal. It's always terminal minus initial. So 9 minus -3, and then 40 minus 11. So that means my vector would be 12, 29. Okay, then to find the magnitude, you do the square root of each part squared. So magnitude would be the square root. So 12 squared is 144. 29 squared is 841. Which is the square root of 985. Which I don't think will break down. It goes, let's see, 5 and 197, no. That would be my magnitude. Okay, now if you're wanting to do operations on vectors, first off, we're not going to talk about how you graph them, what it looks like. So when you get to this part of the homework, that's why it says don't graph. I know adding, subtracting, doubling wouldn't be that complicated. I just want to focus on algebraically, how do we add vectors together or multiply vectors by scalars. Okay? So on 3 and 4, we're going to do 3 parts, A, B, and C. Okay, so for part A, we want to take 2 times V. Well, if this is my vector V, and I want to multiply by a scalar, which is 2, you just multiply both parts by 2. So this vector would be -4, 10. That's all you would do. Okay, for part B, if I want to subtract vectors, so I'm taking W minus V, I would do W, I would match them up, just like we would do like on 2 points to find component form. So this would be 3 minus -2, which would be 3 plus 2, and then 4 minus 5. So this would be 5, -1. Okay, and then for part C, it's V plus 2W, so I have to do the 2W first. So that would be -2, 5 plus, if I multiply these both by 2, that would be 6, 8. So my vector would be 4, 13. Okay, when you get to problems, like the next problem, that have an I and a J, and they will be bold in your book. So this is not an imaginary number. This is called, it's a way of writing a vector. It's using linear combination. So where they would use plus and minus signs instead of using brackets. So this vector right here, which is -2i plus j, that's the same if I wrote it in component form as -2, 1. It's just another way of writing, a different form of how you write the vectors. Okay, but it doesn't change on how we solve anything. So like for part A, if I want to do 2v, I just multiply each one of these by 2. So this would be -4i plus 2j. Okay, so you kind of treat I and j like they're just variables, like you would add like an x plus an x. It's essentially the same thing. Okay, for B, if I want to take W minus V, well, -1 minus -2 would be -1 plus 2, so that would be 1i. And then 2j minus 1j would be 1j. And then for part C, I want to do V plus 2W. So V, I won't change right now. Okay, and then I want to add 2W. So if I add this, this would be -2i plus 4j. And then if I like terms, this would be -4i plus 5j. Okay, so try to be consistent with the form they give you. If it's given to you in component form, leave your answers in component form. If it's given, it's called linear combination. If it's given as linear combination, leave it as the linear combination. Okay, then the next thing, finding the unit vector. If I want to find the unit vector, I take my vector divided by the magnitude. So I'm given the vector, so first thing I have to do is find the magnitude. So if I want to find the magnitude, the square root of each part squared, so -2 squared is 4, 5 squared is 25, so this would be square root of 29. And then I divide my vector by that. So you divide each number in there by square root of 29. Okay, you do need to simplify if numbers will simplify. You do not need to rationalize denominators. If it makes you feel better, because you've always had to do that, you can do that, but you do not. Now, if it'll simplify like 2/4, you'd want to make a half, but you do not have to rationalize. You can leave it like that. Okay, we'll do the same thing with the one that's linear combination, so I just have 4j. So there's no I, so when I go do the magnitude, that'd be like the square root of 0 plus 16, which is the square root of 16, which is 4. So I would just take 4j divided by 4. Well, this one actually does reduce, so my vector would just, my unit vector would just be j. Okay, so that's basically all the formulas. The rest of these examples is I just want to make sure you know what you're doing on your homework. It's using everything that I've already shown you. So it's being able to do component form, magnitude, and unit vector. So everything's going to essentially be the same. I'm just going to be using the same formulas, but doing what the specific directions say. So anytime it says find a vector v with a given magnitude in the same direction as u. So if you are given a directional vector, so I'm given what u is, the very first thing you want to do is find the unit vector. So I'm given u is 3, 3. So the first thing I want to do with this is I want to find its unit vector. So to find the unit vector, we have to take the vector divided by the magnitude. Now, this is not u's magnitude. That's v. So we're doing the magnitude of u. So magnitude of u, square root of 3 squared, which is 9. 3 squared is 9, is 18. Okay, now that's not a perfect square, but that will break down, so you want to break it down. So the magnitude would be 3 square root of 2. So the unit vector of this is, if I take both of those divided by 3 square root of 2, the 3's reduced. My unit vector is 1 over square root of 2, 1 over square root of 2. Okay, then we wanted to have, it's in the same direction, we got the unit vector, but now I wanted the magnitude that it tells me. So now it's going to be the magnitude of v. That means I take my unit vector and I just multiply by whatever the magnitude I want it to be is. So this would be 5. So this would be 5 over square root of 2, 5 over square root of 2. Okay, so same directions, another problem. So the very first thing I need to do is I need to find the unit vector of u. So to find the unit vector, I need to find u's magnitude. So I do the magnitude of u, which would be the square root of, well, 2 squared is 4 and 5 squared is 25. So this would be the square root of 29. So that means my unit vector would be 2 over square root of 29, 5 over square root of 29. Okay, but I wanted the same magnitude as v, so now I want to multiply by 9. So my vector would be 18 over square root of 29, 45 over square root of 29. Okay, so I know I mentioned this a little bit earlier, but there's going to be a little bit of trig here and there, so this is one of the parts that has it. So, do you have to memorize? I mean, you should know your unit circle. If you don't, just use your unit circle to help you. Okay? So, I want to find the component form. So, that means I want it to look like this. This is component form. Okay? And I'm given a magnitude, and this time I'm given the angle. Well, if this is what happens, if I'm given the angle, remember cosine goes with the x, which means it's going to go with the first part of the vector. Sine goes with y, which means it's going to go with the second part of the vector. So my magnitude would go on the outside, and then I would find these values, cosine of 0, sine of 0. Okay, well, if you either know it or use your unit circle, cosine of 0 is 1. So I would substitute 1, sine of 0 is 0, and then I would distribute the 3. So my vector would be 3, 0. Okay, if the angle is not on the unit circle, you can round to 2 decimal places. If it is on the unit circle, I want you to use the exact value. Okay. So do the same thing on to number 10. So this would be 7 over 2, cosine of 150, sine of 150. Okay, well, cosine of 150, so that's an x value, would be negative square root of 3 over 2. Sine of 150 is a half. So if I distribute 7 over 2, that would give me negative 7 square root of 3 over 4, 7 over 4. Okay, and then this last one is similar, but instead of giving you an angle, it gives you the direction. Okay, so if it gives you the direction, you're doing exactly like what we did in 7 and 8, where you're going to find the unit vector first, then multiply by the magnitude. Okay, what's the difference on this one? Well, this one's written as a linear combination. So the first thing you want to do is, since we want our answer in component form, we need to convert this to component form. I is just the first number, the j is the second number. So if I want my unit vector, I find the magnitude of this. I'm just going to call it u. So 1 squared is 1, 3 squared is 9. So the square root of 10. So my unit vector would be 1 over square root of 10, 3 over square root of 10. And then I know my length is 2, so then I just multiply by 2. Once again, you do not have to rationalize the denominator. If it makes you feel better to do it, because that's what you've always done, then that's fine, but you do not have to do it. Okay, this should be able to get you through all the homework on page 456. And like always, if you have questions, let me know. Because this is not, homework's not due until next week. So you have plenty of time.